Welcome back to Hard Problems Made Easy. Today we are going to look at minimum window substring. So the problem statement is that we have a string S and we have a string T. So we need to find a substring that contains all the characters in target T and which is the most minimum of the possible solutions, minimum length of the possible solutions. Let's look at the example that is given in the problem statement. So we need 1A, 1B, and 1C. And this is the target T, and this is the string S, and there are multiple solutions that are of different lengths, right? Of these solutions, we look at whatever is the least length and then give that as the answer, right? So here, if you look at this example, there is an extra b here. We only need one, but we have two here. Let's say this b comes, you know, somewhere between the c and b, but we'll have to keep the other b till we reach a here, right? So those are the kind of edge cases that we'll have to deal with here. So the initial intuition would be that we go over, we slide the window basically, and then compare this dictionary and the dictionary that can be formed with a counter of whatever window we have, and see if we have more or equal to what we need here, right? So that could be a first instinct, but the problem is that is not order of n comparing two dictionaries. So that is why this is a hard problem. We are going to look at how we can do it in order of n time. Let's go to the visualization now. Okay, for this problem, we are having the code side by side with the visual because a lot of the tricky parts in this problem is how we define a bunch of variables that we want to bookkeep so that we don't have to compare dictionaries. Now let me go over this code, the first parts of the code, right? First, we convert this target string into a dictionary. So basically we have this is what we need. We need one count of A, one count of B, and one count of C. That's what we are doing here. And then we are going to have another dictionary that is going to represent our sliding window. So we initialize that here, right? So, and then the next thing is, we look at just having the length of need here so that, we can compare it with the length of the window that we'll be forming shortly. And here we are doing some initializations so that we can return one. Okay, the best length is basically whatever is the shortest length that we can get to. So that is one part of the problem. The other part is, we are looking at bookkeeping the indexes so that we can return the substring from S in the end. So that is how our initializations are going. So let's start iterating and moving the sliding window. So the first part, we are taking a character, and luckily there is one of the characters that we need. So we are putting it as part of the window dictionary and then marking the count of it as 1. Now, since this particular character is part of the need and it fulfills the count here, we are making formed plus equals 1. So the important thing to note here is that if we find more A's in here, we will not keep increasing the formed, right? We will increase this formed count precisely only when the need and whatever is the count in the window is equal. That is the point in which we will be making the length of the formed larger, right? So maybe if we keep going, we'll be able to visualize and understand this better. Um, so now we are, moving the right pointer of the window. We have a character that we do not need, but we still keep going because our substring has to be continuous, right? So we keep going till we find something that we need. B is something that we need, and the count of B here is 1. Count of B here that is needed is also 1, which means we will be increasing the formed to 2, the counter to 2. Okay, now we keep going. These are stuff that we don't need, and then we encounter C, which is needed. Again, the need is equal to the count that we have, so we increase form to 1. Now, what we do here is that we go into seeing, like now we have the solution. We have one solution, and the length of it is 1, 2, 3, 4, 5, 6, right? So that is something that we'll have to bookkeep to see if that is what we need to return or if we can do something better, right? So we go and then like update the best len. It was initialized to float of infinity. So this is like, an initial value so that in case we never find it, then we return an empty string, right? So this is useful for comparison as well. So now we go into updating our best len to what we found here. So now our best length is 6. Okay. Now what we do next is that we we reduce the size of the window from the left side. We move our left pointer till our solution breaks, right? So like we are like moving it, and then like now we are reducing our window count. So previously like A was 1, now it has been like it is out of the window. So that means our whatever is formed here is also reduced. This counter is also reduced, and that is the next tricky part here, right? So only if the number of characters that we need are going to be reduced. See the window for A, now previously we had A count as 1 and we lost that minimum count of 1, so we are reducing the formed. Let's say we had like another A here, right? We will not be reducing the formed here, right? Because we had more than one A and this window would have still been a valid solution, right? So these two parts, right? This formed plus equals 1 and the form minus equals 1, when we do that is the most important part in the solution, right? So whenever the count of the window does not meet the count of the need, right? That is when we reduce the formed minus equals 1. So once we do that, then we now have, uh, we don't have a solution now, right? So we have to keep moving our right pointer at this point. So we keep moving till we find something that's useful. So now we have another B, right? So we need only one B, but we have two here. See, at this point, we could readily uh, keep reducing the window by moving the left pointer, but we do not do that yet. What we do is we keep going till we find all the needed and keep moving the right pointer here. Okay, so now we have another solution here. We have A, B, and C. We also have another extra B. We have the required and formed equal. This means we enter into a loop where we start to move the left pointer, keep reducing the solution, and see if it still holds good, right? So that is what we are doing here. See, even if we reduce all these characters here, including the extra B, these three elements, still meet the need. So what we do here is we go into this while loop, this inner while loop, and then keep reducing the left side, right? And as we keep reducing the left side, the solution still holds, right? So the solution still holds. So we keep updating our best len. I mean, we keep updating our current len, right? So current len is 9. The current len becomes 8, right? So we keep reducing it. Okay, now we have a current length of 7, but whatever was the best length here is 6. So it is still not, even more optimal than 6. So we just leave the best length to itself, and then we go into a state where we do not have all what we need, right? So once we reach a state where we do not have what we need, then we'll start moving the right pointer. Okay. Now, again, we have the solution, but could we do better? We keep moving the left pointer and see if we are able to still hold the solution, right? So this is the point where, this is the best we can do, right? So we have like, all of our need with the counts, and, the length of this is 4. So we update the best length from 6, which was previously 6, to 4 now. And the rest of the program is just a formality. We just keep iterating to see if there is something else. We don't. We already reached the end of the right side, and our solution on the left is already broken. So that's it. We are going to, exit the loop, and then, we have our indexes stored on like what is the left and the right, this B to the C. So we form the substring here using that and return the solution. Hope this was useful. See you in the next video. Thank you.